I told you in self-excited DC motor, we can see shunt motor, series motor, and compound motor. So, in case of shunt motor, and drawing a diagram, how to identify a motor or generator, you first know that one. So, you have to draw a circle. This is the armature terminal A. Turn. Now, so this one actual armature of the motor. So that's the armature resistance is there. So R is equal to armature winding resistance or armature resistance. Now, as we are giving supply to the motor, so this two terminal is there. And this is this is plus, this is minus. The supply voltage is equal to supply. V is equal to supply. Now, when the winding of the field winding is connected parallel to the armature winding, when the field winding is connected parallel to the armature winding, we call it this is shunt. So, field winding resistance. Now, so what is EB? EB is the back EMF. EB is the back EMF. So EB is equal to back EMF. What is back EMF? The armature conductor rotates in a magnetic field. Then the conductor terminus, there is induced EMF, and this induced EMF opposes the cause, that is the supply voltage. That's the reason we call it is back EMF. So this one is the DC shunt motor, where we can see this is the back EMF, this is the supply voltage. Now this current is a supply current, IL. Some part of it is entering to the armature. So this is denoted as IA, capital I suffix A. This current is denoted as ISH. So IL must be equal to ISH plus IA. You have to find out ISH as the supply voltage. Therefore, supply voltage is V and the field winding is connected across. The same voltage V appears across it. So naturally, this V, if you know the V, so you can calculate ISH is equal to V by RSH. ISH, that is the shunt current, is V by RSH. And the input power is equal to PL is equal to IL into V. So you can directly, if you know the specification of the motor, you can calculate the load current also. You know the supply voltage. So you have to remember the equation. This is number one equation. This is number 2 equation and this is number 3 equations. Using these 3 equations, you can solve problem. Another equation is there. The terminal voltage V is equal to back EMF plus this drop plus IARA drop inside the armature plus BCD. BCD stands for brush contact drop. So BCD stands for brush contact drop. If it is not mentioned in the numericals, that means you have to consider it as 0. So terminal voltage is equal to back EMF plus IARA plus BCD. If I consider BCD is equal to 0, then what is back EMF? Back EMF, EB is equal to from this, EB is equal to V minus IARA. V minus IARA. Okay? Okay. Why we need a starter in DC motor? If you see the initial current from that, this initial current IA is equal to what? V minus EB, V minus EB by RA. Initially back EMF is equal to 0. So this part is 0, the V by RA. So naturally huge current flows in the armature winding. That's why we need the 3-point starter.